All right, I want to give everybody a quick rundown about how to do this ecological data lab. Let's see, today is the 24th, so I'm probably going to give you guys until the middle of next week to get this done. I wouldn't recommend taking that long, but you can if you want. So anyway, let's go ahead and start by finding, this is our lab ecological data introduction. It's not published yet. This video doesn't exist yet, but let's go ahead and go to the Ripon collection site data. And we're just going to go ahead and click on that. It's going to do this thing, but I want to download it. So let's see, how do we do that? Click again, go to Save File, and then I'm going to go up here and I'm going to type in sheets.new. And that's going to take us to a brand new Google document or Google Sheets document. You could use Excel if you wanted to, but I really highly don't recommend it. I won't be able to help you with that. Or I might be able to help you, but it's going to be a big pain for everyone. Plus, Google Sheets is free. The only thing you need is a Gmail account. So let's go over here and go to File. Let's go to Open, and then let's go to Upload. So let's do that one more time. I went to File, then I went to Open, then I went to Upload, and I got to this page by going to Sheets.new. So let's do it one more time. File, Open, Upload, and I downloaded this here, and so I use Firefox, so it's going to pop up right there for me, but if you click select a file, you can just go to your downloads, find that file, and there it is. I'm going to go ahead and change the title of this by just adding my first and last name to the end, and you should do that too, so I know who you are when you turn it in. And you can see here we have all this really interesting looking data that I got from a colleague, and I actually edited this, so the errors we may find aren't from the data itself necessarily. It's because I artificially introduced it. And let's just take a look at this data. So the first thing I notice is that there are dates over here, and there are numbers for some of these things, and for some it's just NS, which I believe means no sample. And then there are others in here that say like ND, which I believe means no data. That doesn't matter to us. We're going to treat those the same. We're just going to pretend like they don't exist, or we're just not going to factor them in. Let's talk about these different things that are being measured here. Dates, you guys should know, are just dates. Turbidity has to do with how easy it is to see through the water. So actually, let's look this up. Let's go for turbidity, and let's look up an image. You should see that the more turbid water gets sort of like darker or grosser looking. Let's do turbidity standards. So there you go. These are more turbid. These have a higher turbidity as you increase through the alphabet here. This one is the most turbid. This one is the least turbid. And yeah, it's measured in NTU. I just wanted to give you a sense of what we're actually looking at. DO stands for dissolved oxygen and can correlate with how healthy an ecosystem is. And we're going to see that that fluctuates through the year. And then there's water temperature in here in column D, which also is obviously going to fluctuate throughout the year. So we've taken a look at our data. We've seen a few things. This goes from the 10th of September all the way to the 2nd of December. So like almost 4 months or something like that. And so that's kind of a lot of data. So now that we've kind of got an eyeball of this, I'm curious how many data points we actually have. So I'm going to go ahead and click on this A right here. Just go ahead and click on that. And then if you right click, you can go to Insert One Left, which is going to do just that. It's going to insert one on the left side. And I'm just going to go ahead and put sample number. I'm just adding this because I'm curious how many samples we actually have. So I'm just going to type 1, 2, 3, 4 right here. So we've got 1, 2, 3, 4 on our sample number, and then I'm going to hold down the Shift key and use the arrow keys, or you can just click and drag until you have all of these things selected. Once you've got them all selected, take the cursor to the bottom right-hand corner until it turns into a black X. So let me do that one more time. I'm just going to select these data, then I'm going to go to the bottom right-hand corner until my cursor turns into a black X. Once that happens, I'm going to click and drag down. Don't let go after you click. So I'm still holding on the click, and I'm just going to drag down until I get to the very bottom of these data here. And you can see it's going to automatically number them, and we have 84 data points, 84 different pieces of information about the turbidity, dissolved oxygen, and water temperature at this particular site. I believe this site is in Oakdale. So now that we've got that, we're just going to do some scratch statistics or some summary statistics over here. So I'm going to just type in turbidity. I wish I could spell turbidity min. We're going to say turbidity max and turbidity average. What we're doing now is we're looking for bad data points, and we're also getting a better overall sense of these data in general. So the way we're going to do this, the way we're going to figure out what the minimum value in this entire column is we're going to start by typing an equal sign. You always start typing a function in Sheets or Excel or whatever spreadsheet program you're using, unless it's like a, what do you call those, a relational database or whatever, which is neither here nor there. But in order to figure out the minimum value of this entire column, I'm going to say, let's go back here, we're going to say equals min, and it says minimum value in a numeric data set. Cool, so that's good so far. Let's do that one more time. I'm going to type in equals min, and then I'm going to press Shift 9 to open up a parentheses. So when you do this, this is the function here. This min thing is the function. And whatever you put in these parentheses, that function is going to do an operation on that. And I'll show you what I mean. So I'm going to say, what is the minimum value between C3 and C, where does our data set go to again? Let's scroll down and find out. Our data set goes to C86. So between C3 and C86, our minimum value appears to be 0.15. And if you double click this, it'll actually show you, hey, I'm figuring out something. This function is operating on whatever is highlighted in orange here. Smallest value in turbidity is 0.15. Great. Fantastic. So we're going to figure out the max value now, and it looks something very similar. So I'm going to say equals max of C3 through C86, I think is what we said. Okay, cool. Make sure. Yeah, C86. So the largest value in turbidity is 5.09, and we're going to say equals average C3 through C86. Our average value is 1.7. That's fairly reasonable, I think. Neither of these are preposterously too large or preposterously too low. So far, so good. I just erased those values because I don't really care about them. We're just trying to figure out, do we need to do any edits? Do we need to call someone and figure out what's going on with this data set? So let's do do min, and we're going to do do max, and we're going to go do average. And we're going to just do the same thing for column D. So I'm going to type in equals min, D3 through D86. So remember, it's kind of like Battleship. It's set up in a coordinate or a grid system. So this is D3, this is E3. You can go as far as you want. If you get to the very end of the alphabet, it just starts doubling up. And so these things are, I won't say limitless, but you can put a lot of data into a simple spreadsheet like this. Okay, our minimum value, 8.09. That seems pretty reasonable. Let's say equals D3 through D86. I'm sorry, equals max D3 through D86. Okay, that's a problem. I think equals average D3 through D86. By the way, that is, you guessed it, that's getting our average value. Okay, so this number seems like it's kind of beyond the pale. It's like way bigger than our average value. It's like preposterously larger than our minimum value. Just glancing at these things in general, it looks like it's considered on November 25th, and we have these three pieces of data. And what could have happened is somebody could have accidentally moved a decimal point or whatever the case may be. But I'm not sure, so I'm going to just go ahead and replace this with ND. Actually, first, We're going to replace this with ND in a moment, but we need to take some notes first. So I'm going to go ahead and just go over here, and I'm going to click on F, and then I'm going to right click and go insert one left, and up here I'm going to type in notes. And we'll just, if you click the paint format button, so if you select the E2 and then you click paint format, and then you click on the cell that you want to change the format of, it'll change the cell for you. It's neither here nor there. I'm not super worried about that right now. But we're adding a notes column, so let's go ahead and find where that is. By the way, I'm kind of just jumped ahead there, but if you select this and you go edit copy, and then you press the control key and the F key, or alternatively you can go to edit, find and replace, and then we paste that in here and we can just find things. So there is our outlier value. We're over here in our notes column. We're looking at our outlier value. Find it one more time. There it is. And when we're working with any kind of scientific data, it's very important that if we do anything to the data, we need to keep like very, very, very good notes. So we're going to replace this because it's kind of preposterously large, but we're going to just say outlier value found in DO. Double click to start typing again since I clicked off of it on accident. Or you could also, if you click on this, you can also type up here. It's the same thing. But we're going to say outlier value found in DO 343.22 replaced with ND. Okay, no data. And we're just going to go ahead and leave these two alone because that's fine. So we got our notes. We have our notes about what we did. So, you know, if somebody calls us and says, no, that's a good value. The dissolved oxygen was super, super high that day because of whatever reason. Which 343.22, it's not real. It's a bad reading. Okay, cool. So DO, so this, now that we've replaced that, it updated with this number. So it used to say 343.22, but we got rid of that, and now it says, now the highest number in this column is 96.9. So let's find that one. Control F, we'll find that. Okay, so this is here. It says 96.9. It really seems to me like it's an outlier. It seems like somebody tried to put 9.69 in here, but they accidentally said 96.9. So we're going to say outlier found in DO, 96.9 placed with ND. Put an ND here, cool. And then our next one is a lot closer. You know, it's not like an order of magnitude larger than our average. Okay, so I'm good with our DO values now, and we took copious notes and made sure that we replaced everything that we needed to. So I'm going to go ahead and get rid of this because we don't care about it anymore. And let's do the same thing for temp. Temp min, temp max, temp average. And I'm going to let you guys actually go through this process and see if there are any water temperature values that are way too big, way too small, don't fall within what you think they should be for a river that is actively flowing in the Central Valley, which means it's never really going to freeze, by the way. Okay, and I'm going to let you go ahead, go through that, and eliminate any outliers that exist there. So now that we have, hopefully, our data cleaned up a little bit, let's go ahead and make a chart. So I would like to see the date versus turbidity, the date versus dissolved oxygen, and the date versus temperature on 3 separate graphs, and then I think maybe let's combine them all into one and see what that looks like. So to do this, I'm going to go ahead and click sample date and just drag all the way to the bottom. And then we're going to scroll back to the top, and then I'm going to press and hold the control key. So while pressing and holding the control key, I'm going to select. We'll start with our water temperature. Just press and hold the control key and drag it all the way down. Or, you know, alternatively, there are other ways of selecting a bunch of data. So like we could just press the B up here, just click on that, and then if you press and hold control, you can click the E and it'll select this whole thing. And there's a couple extra cells, but that doesn't matter. Sheets is smart sometimes. So then we're going to go to data, and then we're going to go to insert rather. We're going to go to insert a chart. Okay, cool. So maybe there is a problem here. Maybe we do have some data that we still need to clean up. That is neither here nor there. But you need, yeah, that's for you guys to do. But you may need to change the chart type. Like it might give you something weird looking. Like you don't want an area chart. You really don't want like a stacked bar chart. It's kind of cool looking, but not quite what we want. You know, a stacked column chart doesn't really make any sense in this context. Pie charts doesn't make any sense. You really want just a line chart. Okay, that's for our temperature and sample date. So I'm going to click B again and then press and hold the control key and then click this D up here. Let's do that one more time. You click on the B itself. You can hold control right now if you want to, but you don't have to. I probably wouldn't actually because you can wind up grabbing other data that you don't want. So click B and then press and hold control and then click D. Then we're going to go to insert chart. And then, we have some gaps in our data, and that's totally fine, kind of what we maybe expected even. You can use a scatter chart. Scatter chart would be fine too, since the data is not continuous. That actually, let's go ahead and use a scatter chart since our data is non-continuous like that, so there's no gaps or anything. And that looks reasonably clean to me, and you can kind of see the dissolved oxygen changing throughout time. In fact, if we go to customize, and let's see if we can find it. I'm trying to figure out how to add a trend line in Sheets. I wonder if we can just do it here. No. So I don't know how to do it, so I'm going to go add trend line in Sheets. On your chart, double click, customize, optional, next to apply to, choose the data series you want to add the trend line to. Okay, we're going to go back here, customize. What? Click customize, series. Okay. Data point. Oh, here we go. Trend line. There we go. And so you can see that the dissolved oxygen is, the trend is that it is increasing as you get further into winter. So I want you guys to add trend lines to all of these charts, actually, just so you can get a better sense of what they're doing. So let's do that all one more time. I'm going to go ahead and click B. We don't need this. I'm going to go ahead and click B and then press the control key and click on D. You go to insert chart. Nifty, I said to use a scatter chart for this non-continuous data. Then you go to customize. So we were here, now we go to customize. You go down to series right here. If you click series, then we can click trend line. Data labels, not particularly useful for this much data. Error bars, I don't know what error bars Sheets uses, so those also aren't particularly useful for this. So get rid of that, and we're just going to use a trend line. All right, great. You guys, you should leave this chart here. I would probably pull it off to the side so that it's just over there. Now let's just do the same thing. We're going to click B, press Control and C, and then you're going to go insert a chart. Okay. So I want charts for sample date versus turbidity, sample date versus DO, sample date versus water temperature, and then we're going to do all of them. So again, you press the B and then you hold the control key and click all of them. We go to insert charts, and it should show us, all of these different data points. Let's try a scatter chart and see if that looks any nicer. It does look quite a bit nicer. And so now we can see what these different trends look like over time. You will not need a trend line for this last one. Okay, so that's how you do sort of like the mathier parts of this. Make sure you are validating your data. Make sure that all of your data makes logical sense to you, and then make those charts. And then you can turn it in on Canvas. I'm also going to have an instruction page with a few questions, although the instructions are almost forgot. So if you have some
chart that you've created here, you can just go to edit, copy, or you can just press Control C, bring it over to here. I already pasted it, but we'll paste another one. And we're going to paste unlinked. You always want to paste unlinked when you're doing these things for this particular format anyway. So just paste unlinked. There's our chart. You can kind of play with it and see what you think looks best. But yeah, go ahead and paste in all of your questions to this document that's going to be on Canvas. Answer these questions and turn it back in. All right, cool. Let me know if you guys need anything.